In the watts, amps, ohms, and volts video, I explained how current and resistance is like water flowing through a hose. Now, I'll use those concepts to show how dual, parallel coils work. Imagine these are wires on two different atomizers. Out of the two, the thinner wire has a higher resistance because the current flow is more restricted. But if we add a second wire like this, the current has two wires to flow through, so the resistance drops. If the length and thickness of the wires are about the same, the resistance is cut in half. Here's how it looks on a dripper. If we have a single 1 ohm coil, the resistance is just simply 1 ohm. If we add another 1 ohm coil in parallel, the current will flow through two wires, so the total resistance is reduced to 0.5 ohms. To get 1 ohm using two coils, each coil will have to be 2 ohms. So we end up using 4 times more wire than a 1 ohm single coil build using the same wire. Coils are considered to be in parallel because of how they're wired, not just because they look parallel. Each coil has to have one end connected to the positive post with the other end connected to ground. But as you can see, this atomizer has 2 ground posts. So I can place the coils like this and it'll still be considered parallel. It's wired like the diagram. And these ones as well. But a build like this is not. There are 2 coils, but it's made using 1 wire. For dual coil to work properly, the resistance of each coil has to be roughly the same. Otherwise, the current does not split evenly, so the coils don't fire evenly. This is the equation to calculate parallel coils. You basically divide the resistance by the number of coils. We already know that with 2 coils, the resistance is half. But if there are 4 coils, it drops the resistance even lower. Remember, this is only if each coil has roughly the same resistance. Or else, the equation is not so simple, which we will never use anyways.